Now our series is the sum as n goes from 1 to infinity of negative 1 to the n minus 1 over n times 5 to the n times x to the n. Finding the radius and radius, finding the radius and interval of convergence. We're going to use the ratio test. The limit as n approaches infinity, you know what? I want you to do it. Come back after you have found the radius, and then we'll take care of the endpoints of the interval together. Fleshing out the ratio test, we have the limit as n approaches infinity of x to the n plus 1 divided by n plus 1 times 5 to the n plus 1 times the reciprocal of the nth term, n times 5 to the n over x to the n. Forgot to mention it was in an absolute value, and of course we dropped the negative 1 to the n minus 1. All but one factor of the x are going to divide out. All but one factor of 5 is going to divide out. That leaves us with this x over 5. As far as n over n plus 1 is concerned, the limit as n approaches infinity for that is going to be 1. Therefore, this will converge using the rules for the ratio test if the limit is less than 1. So here, if the absolute value of x over 5 is less than 1, clearing the fraction, that means that the absolute value of x would be less than 5, and that gives us our radius of convergence. Working with the inequality, we have that x is going to be between negative 5 and 5, and that gives us the endpoints for the interval, and that's what we're going to test separately now. Now, I want to make clear, what we're testing is the original series, and we're just going to substitute x by negative 5 and then 5 one at a time. And I don't want anyone to be confused about, like, why are we writing the negative 1 here and we didn't write it when we used the ratio test? At this point, we're not doing a ratio test. We're seeing what this series looks like when x is equal to, for instance, negative 5. We'll start there. We're going to have the sum as n goes from 1 to infinity of negative 1 to the n minus 1 times negative 5 to the n divided by n times 5 to the n. Now, if we consider just negative 5 to the n over 5 to the n, folks, they have the same exponent. Using properties of exponents, we can write that as the fraction negative 5 over 5, whole thing to the n. That becomes negative 1 to the n. That combines with the other negative 1 to the n minus 1. This then becomes the sum as n goes from 1 to infinity of negative 1 to the 2n minus 1. You see the negative 1 to the n minus 1 and the negative 1 to the n's add. And we get 2n. The denominator is simply n because we already dealt with the 5's. 2n minus 1 is an odd exponent. Folks, this numerator is always negative, which means it is not alternating. And this is a harmonic series. In other words, it's a p series with p equals 1. And so this diverges. It's a p series with p less than or equal to 1, and so it diverges. For x equals 5, I'd like for you to pause the video and see if you can come up with the convergence behavior for that endpoint. Letting x equal 5, that's a weird way to put it. Letting x equal 5, like how would you prevent x from being 5? Anyway, letting x equal 5, we have the sum as n goes from 1 to infinity of negative 1 to the n minus 1 times 5 to the n over n times 5 to the n. Those 5 to the n's are just going to divide straight out. And we're left with the sum as n goes from 1 to infinity of negative 1 to the n minus 1 over n. That is the alternating harmonic series. You'll find that converges by the alternating series test. Therefore, we've already set our radius as 5. The interval of convergence is the half open interval. Open at negative 5, closed at 5. Let's do another one. The sum as n goes from 1 to infinity of negative 1 to the n divided by the quantity of 2n minus 1 times 2 to the n times x minus 1 to the n. Now our base is a little different. We've got x minus 1. Now what I'd like for you to do is pause the video, come back when you have the radius of convergence. For the ratio test, we've got the limit as n approaches infinity of the absolute value of the n plus first term, which is x minus 1 to the n plus 1 divided by the quantity 2n plus 1 times 2 to the n plus 1 times the reciprocal of the nth term, which is 2n minus 1, that quantity times 2 to the n divided by x minus 1 to the n. All but one factor of x minus 1 divides out. All but one factor of 2 divides out. We're left with the limit as n approaches infinity of 2n minus 1 over 2n plus 1 times x minus 1 over 2. I like to combine the n's together because then it's easier to see that that limit is 1. And we have the limit as n approaches infinity of the absolute value of x minus 1 over 2, which will converge if that absolute value is less than 1. Clearing the fraction, that means that absolute value of x minus 1 is less than 2. Here we have a radius of 2. Now what I'd like you to do is continue on with this inequality, figure out what the endpoints are, and then figure out convergence behavior at both of those endpoints. Come back when you're done. After solving the absolute value inequality, absolute value x minus 1 is less than 2, we get that x is between -1 and 3. Those are our endpoints. Substituting x equals -1 in place of x, we're going to have a base of -2, and that'll be to the n power. So we have the sum as n goes from 1 to infinity of -1 to the n times -2 to the n divided by quantity of 2n minus 1 times 2 to the n. The 2 to the n and the -2 to the n, they divide out, leaving -1 to the n. Combining -1 to the n with -1 to the n that was already sitting there, we get -1 to the 2n. That is an always positive numerator divided by a denominator that is 2n minus 1. Folks, we're looking at a comparison test at this point. 1 over 2n minus 1 is less than 1 over 2n. And we know that the sum of 1 over 2n is divergent because the 2 in the denominator doesn't affect convergence, and 1 over n is a p-series with p less than or equal to 1. Folks, sometimes people refer to something like 1 over 2n minus 1 as a p-series. It isn't. As long as there's that minus 1 down there in the denominator, it's not a p-series. Okay? Anyway, at x equals -1, we have divergence by the comparison test. For the endpoint x equals 3, substituting 3 in place of x in the base x minus 1 to the n is going to give us a 2 to the n. The 2 to the n's are going to divide out. We are left with the sum as n goes from 1 to infinity of -1 to the n over 2n minus 1. That is convergent by the alternating series test. Therefore, we already wrote down that our radius was 2, and here, I boxed it in pink for some reason, we have an interval that goes from -1 to 3, open at -1, closed at 3. Now, we keep having intervals where the left endpoint is open, the right endpoint is closed. That won't always be the case. Don't take it for granted. I do need you to check the endpoints every time.